Well, good morning to all of you. Good morning, everyone, class. Good morning. Good morning. Good morning. Good morning, everyone. How are you all doing, boys and girls? Doing good? And I hope you are doing the homework as well. You are doing the questions as well. Good. Very good. Very, very good. So, like, we are having some serious stuff online, and that's good to see that. Surya, you have to do the assignment in terms of the module till what we are teaching on a daily basis. Hai? Pick up the module and keep on doing that. Getting it? And if you're not having that stuff, I'll be asking the management to send you as soon as possible. Okay? So shall we begin the today's class? So today, okay, they will provide you. They will provide you, Surya. Don't worry at all. They will be providing you. So in the meanwhile, can we begin the today's topic? So we have in the previous class, what we have done? We have done that electromagnetic wave theory was not able to explain the four phenomena. Which were they? They were like black body radiation, photoelectric effect, spectrum of atom, and heat capacity change in solids with temperature. Yeah, correct. So in the last turn, we have seen the black body radiation. Hai na? Today we'll be studying the photoelectric effect. So shall we begin? Okay, chalo, come on. So write down photoelectric effect. First, write down the definition. Please write down definition. Everyone, please write down definition. It is the emission of electrons. It is the emission of electrons from metal surface when it is the emission of electrons from the metal surface when light of suitable frequency falls on it, or you can say is incident on it, falls on it. Getting it? Suitable frequency. Right? So let's see the diagram first and then I'll explain you this thing. So see this thing, what photoelectric effect is trying to tell you. It is the setup just like cathode ray tube. You are having a cathode and you are having an anode. This is positive, this is cathode, which is negative. This is positive, this will be anode as usual. Okay. Now this cathode is actually made up of metal. These metal, preferably they are potassium, rubidium and cesium. Potassium, rubidium and cesium. Here you have applied the voltage as such. Now see that if a light is incident on this metal surface, some electrons can be ejected. These electrons are called photoelectrons. The electrons emitted by the photons. Now over here, before I move forward, I want you people to write down a very, very important thing. They ask you, very important, that photosensitivity. What is the order of photosensitivity? They will give you lithium, sodium, potassium, rubidium and cesium. So the order will be this one. And what's the reason for that? What is the reason for that? The reason is that as you go down the group, lithium, sodium, potassium, rubidium and cesium, as you go down the group, what happens? Come on. The size increases, and as a result of size, the ionization energy decreases. That is the amount of energy required to eject electron, okay, decreases. Yes, radius increase, and because of that, the ionization energy will decrease. Yes, okay. So as the amount of energy required to eject electron or remove electron decreases, it will become easier for us to eject the electron. So this is the order. Very, very important. Very, very important. Okay. Now see, Now see one very, very important thing, very, very important thing, है ना? Like say failure of electromagnetic wave theory, which is also called classical theory, also called classical theory. So this classical theory, or you can say electromagnetic wave theory, which was given by Maxwell, since we know that it was not able to explain the photoelectric effect, like there are certain things of photoelectric effect which this theory was not able to explain. So let's see what were those factors. I mean, there are two factors. First one was could not explain absence of time lag. Absence of time lag. I'll explain you what I'm saying. They could not explain the absence of time lag, which means according to these people, there is something called time lag. What is that? Wait for that. Second one, they could not explain, again, threshold frequency. They could not explain the concept of threshold frequency, which you will write down at nu naught. Or you can say they could not explain the threshold energy, which will be nothing but h nu naught. H nu naught. In last lecture, we have seen that if you multiply frequency by h, it will become energy. So energy was equal to nu. Remember that? So E will be equal to h nu. So energy is equal to h nu. In this case, we are saying the threshold energy is called nu naught and the threshold energy is h nu naught. So if you want to write down the definition of threshold energy, you can write down it is the minimum energy required. It is the minimum energy required to eject an electron from metal surface. It is the minimum energy required to eject an electron from the metal surface. So these two things were not explained by the electromagnetic wave theory, which is otherwise called classical theory. Okay, come on now. Let's do the observations of photoelectric effect. So when they were conducting the experiment, they observed something. Like in science, observation is very, very important. What you observe, what you note down is something fact. Okay, and if your theory is not able to explain this fact, that means something is wrong with the theory, nothing with the fact. Facts cannot change, theory will be changing. You have to change the theory or you will be discarded up. It was time to change the electromagnetic wave theory from that point of view. So the observation number one, the first observation which was made was this, basically, that there was no time lag. There was no time lag. But according to classical wave theory, there was something called time lag. Okay, there was no time lag. Second one, the number of photoelectrons ejected or emitted was proportional to intensity of light, was proportional to intensity of incoming light. Here intensity bachcho means number of photons. That means more the number of photons, more is the intensity of the light. So number of photoelectrons ejected was proportional to the intensity of the light, or you can say number of photons incident on the surface of the metal. Okay, third one, every metal has a characteristic threshold frequency. Nu naught has characteristic threshold frequency below which photoelectric effect will not be observed. This characteristic frequency is called threshold frequency, which is the minimum amount of frequency required, okay, to eject the electron. Fourth one, the kinetic energy of photoelectron is proportional to the frequency of the incoming photon. is proportional to the frequency of the incoming photon. Are you getting that? So more the frequency, more the energy. So higher the frequency of the photon, higher the energy of the photon as well. Okay. Then the last one. And what is that? Kinetic energy of photoelectrons is proportional to the frequency of the incoming photon. Yes, correct. Ask. Be quick. Be quick. Okay, now see that. Fifth one. If nu is less than nu naught, that means what is nu? What is nu? Nu is the frequency of the incoming photon, and nu naught is what? Threshold frequency. If nu is less than nu naught, that means what? H nu will be less than H nu naught. Will be less than H nu naught. Okay? If that is the case, that means if the energy of the photon is less than the energy of the or the threshold energy, then there will be no photoelectric effect. There will be no photoelectric effect being observed. No ejection will be there. There will be no ejection whatsoever. I'll explain that. Just write down the final statement, and after that only explanations will be coming. Now see this thing. If nu, that means the photon frequency is more than the threshold frequency, which actually means H nu is more than H nu naught. In that case, what will happen? If the photon energy is more than the threshold energy, photoelectric effect will be observed. It will be observed. Are you getting it? Okay. Now let me explain these things. And before that, there is one more thing. 6th point. According to Einstein, one photon interacts with one electron at a time. One photon interacts with one electron at a time. That means what? An electron cannot store energy of more than one photon. It does not have any mechanism to store the energy. Are you getting it? Now let me explain what is happening around. Like according to the classical theory, or say electromagnetic wave theory, what is happening? According to these people, like say this is the metal, you know? So it is having the threshold energy of say H nu naught equal to say 5 electron volt. How much? 5 electron volt. Now this is also called phi, which is also called work function. You can say it is work function, or you can say it is say threshold energy, which is one and same thing. So either they say work function or they say threshold energy. This is nothing but one and same thing. Now what I'm saying is that according to classical theory, they believe that light was a form of a wave, and this wave was carrying the energy continuously. According to classical theory, the energy moves continuously. Light is the wave, and wave are continuous in nature, so it will be carrying the energy continuously. So I'm assuming that they say this light which is coming is bringing say 2 electron volt per second, 2 electron volt energy per second. Now according to classical theory, since the minimum energy required to eject the electron is 5 electron volt, so they were saying that this light is coming with energy of 2 electron volt per second. That means it will keep on, this electron over here will keep on absorbing the energy at a rate of 2 electron volt per second. So it will take 3 seconds to become 6 electron volt. So once this energy becomes 6 electron volt, electron will be ejected with what? 1 electron volt kinetic energy. The kinetic energy will be 1 electron volt after how much? After 3 seconds. After 3 seconds. This delay was called time lag. According to these people, they said that howsoever weak the photonic energy is, or the energy of photon is, they will be able to eject the electron after some time, if not immediately. This time taken for the ejection of electron is called time lag. According to classical theory, this existed. But when the experiments were conducted, they found that no, there is no time lag. Either the electron will come immediately or it will never come out. It will never ever come out. This was explained by Einstein. And how Einstein proved it? He was inspired by Max Planck. According to Planck, boys and girls, according to Max Planck, energy, we have seen that, is quantized. And he said energy existed in the form of packet, which he called quanta. Einstein said that whatever Max Planck is saying is correct. That means light, which is nothing but a form of energy, is also quantized. It travels in the form of packets, and these packets Einstein called as photons. And each packet has an energy called h nu. The way this packet was having the energy called h nu. Are you getting it? Is that clear? So first thing Einstein did was that to refute the classical theory, which said that light will be moving in the form of wave, that too continuously. He said no, Planck was correct. Since light is also a form of energy, and it has been proved by the Planck that energy is quantized, so the light is also quantized. Light is having a particle nature. It moves discretely, discontinuously in the form of packets, which he called photons, and energy of each photon is given by h nu. Now Einstein further explained that suppose this is the metal who has a work function equal to, say, h nu naught, which is the minimum amount of energy required to eject the electron, is, say, 5 electron volt. Is how much? 5 electron volt. Are you getting that, boys and girls? Now he said that if a photon is coming of energy, say, 2 electron volt, he said that this 2 electron volt photon will never be able to eject an electron. No chance. He said that one photon can interact with one electron, or vice versa. One electron can interact with one photon. Is that clear? There is no chance that you can say that this electron over here will be able to absorb the energy of the 3 photons. No. Either the photon is having sufficient energy, or else electron cannot store the energy. It's just like that. Let me take an example. Let's say we are having a bottle. Get it? So now if you want this bottle to fall down, the amount of energy, minimum amount of energy required is, say, 5 electron volt. Suppose a photon comes and strikes over here with 1 electron volt energy. The energy required is red. The energy required is 5 electron volt, and the incoming photon is, say, 1 electron volt. It will strike there, but this bottle will not fall, and this bottle is not going to store the energy of the incoming photon as well. This photon will come and will depart. It will take its own energy, but this bottle will not store the energy of this photon. Yes or no? Like, say, 1 photon coming, 2nd photon coming, 3rd coming. Now they will all come with 1 electron volt energy. They'll keep striking, they'll keep on going, but this bottle will not fall down. Now suppose 1 photon comes with 12 electron volt energy. The energy required to make this bottle fall is 5 electron volt. Now what will happen? They'll strike over here, and this bottle will fall with the kinetic energy of 7 electron volt. 7 electron volt. Is that clear? Yes or no? That's good. That's really good. So over here, so he said the electron is never ever going to come out. You keep waiting for infinite time, nothing will happen. But suppose we are having the same metal, boys, and pi equal to, that is h nu naught, is equal to, say, 5 electron volt. So the electron over here, the minimum energy required to remove this electron is 5 electron volt, and now a photon comes of 12 electron volt. It will strike there, and the electron will be ejected with a kinetic energy of how much? 7 electron volt. Yes or no? 5 electron volt will be required to just bring it on the surface, and remaining 7 will be its kinetic energy. Is that clear to everyone? Suhas Gowda, everyone out there, are you getting that? That means this electron will come out with a kinetic energy of 7 electron volt, and that too immediately. Are you getting that? Immediately. There is no time lag. Yes or no? So Einstein was able to prove that there was no time lag. Trishal, Nayak, very good. Extremely good. Yes or no? It will come immediately. Boys, getting that or not? Immediately. No time lag. So it was like Einstein was able to explain the absence of time lag by assuming that light is what? Discontinuous. It is moving in the form of particles or say packets. The way Planck told. Yes, correct. Okay. Now see, few more things. Very, very important. Very, very important. Einstein further told what? That if nu is more than nu naught, that means if h nu is more than h nu naught, electron will come out. Photoelectric effect will be observed. Remember that or not? Now understand very, very important thing. Now what he said was that kinetic energy of photoelectron is proportional to frequency of light. Frequency of light, or you can say photon. Frequency of photon. Yes or no? Because I know that this frequency of photon is like nothing but the energy of the photon, or you can say what? Energy of the photon. Yes or no? So what I'm saying, see that we are having a metal, and phi h nu naught equals to 5 electron volt. I'm taking an example. Suppose the photon comes of say 8 electron volt, strikes over here. What is the kinetic energy? Come on. What is the kinetic energy? It will be 3 electron volt. Yes or no? Now take the second case. If phi is equal to h nu naught, which is equal to say 5 electron volt again, and a photon is coming incident over here of say 12 electron volt, the kinetic energy of the electron will be, will be equal to how much? 7 electron volt. That actually means more is the energy of the photon. More is the kinetic energy. Will you all agree with me? So kinetic energy of the electron depends on the energy of the incoming photon. Suppose if I make it like say the photon is like say 20 electron volt, this is again 5 electron volt, the kinetic energy will be equal to how much? 15 electron volt. Yes or no? 15 electron volt. So more is the energy of the photon, more is the kinetic energy of the electron being ejected. Is that clear? Sure about it? Very good. Very, very good. So now understand one more thing, bacho. Very, very important. So let's draw something over there. So let's take this example. So this was the 8 electron volt, the energy of the photon, which was equal to what? 5 electron volt plus 3. If I apply the conservation of energy, this 8 was distributed in the form of 5 and 3. 5 electron required to just bring the electron outside the surface of metal, and 3 the kinetic energy of the electron. Yes or no? So what is this 8? 8 is the energy of the photon, which is called h nu. Yes or no? Which is called h nu. Energy of the photon, h nu. What is this? 5. It is h nu naught. The threshold, yes, threshold energy, h nu naught. And what is 3? The kinetic energy. Will you all agree? Good one. So can I rearrange it again, and this will give me kinetic energy is equal to h nu minus h nu naught. H nu minus h nu naught. Now we have to plot a graph of that. Very, very important. So I'll take what? I'll take kinetic energy on the y-axis. Y equal to mx plus c. Y equal to mx plus c. Understand, this is very, very important. Y equal to mx plus c. So according to this part, my kinetic energy is where? On the y-axis. What is my slope? Planck's constant. And what is on my x-axis? Frequency of the incoming photon. And what is my intercept? Minus of h nu naught. Wait. So this is say kinetic energy on the y-axis. This is say frequency. So what will be the intercept? Minus of h nu naught. Since h is also positive, nu naught is also positive. So overall h nu naught will be positive always. Yes or no? Planck's constant value is always positive. Planck's constant is how much? H is equal to 6.6 10 to power of minus 34 joule second. This value is always positive. Frequency is always positive, always positive. So positive into positive will give you positive, but there is a negative sign. So overall this becomes negative. That means intercept will be negative. And intercept is where? On the y-axis. So this value will be minus of h nu naught. H nu naught over here. Okay? Yes, good one. Now what is slope? Planck's constant. This value is negative or positive? Planck's constant is negative or positive? Come on. It is always positive. So when the slope is positive, it will be like this or like this. First one or second one? Slope is positive, it will be first one. Very good. So a line should be passing which should cut an intercept over here, and it should have a positive slope. The line should be something like this. The line should be something like this. Yes or no? And the slope of this line will be Planck's constant. Slope of the line will be Planck's constant. Is that okay or not? Yes or no? Okay, that's good. That's good. Now, who will tell me what is this line or what is this point? Over here, if you are focusing, over here, if you are focusing, you can see kinetic energy is 0. Kinetic energy is 0 over here. Yes or no? So if I put kinetic energy equal to h nu minus h nu naught. If I want this to be 0, because at this point on this line, entire line, the kinetic energy is 0. Yes or no? So this will be 0. This is only possible when h nu is equal to h nu naught. So h and h will cancel. Nu must be equal to nu naught. That means on this point, the value of nu will be nu naught. Yes or no? That actually means if the energy of the photon is equal to the threshold energy, electron will just come outside the metal surface but will not have any kinetic energy. Yes or no? Yes or no? And if the frequency of the photon is less than nu naught, it will have a negative kinetic energy. This is having negative kinetic energy, which is not possible. Which means there will be no ejection of electron. Yes, there will be no ejection of electron. Is that clear? Is that clear to all of you? Yes or no? Good. Very good. Very good. So remember this graph. This is very, very important. So overall, the final equation is what? That the kinetic energy of the electron ejected is equal to h nu minus h nu naught. Sometimes this h nu naught is written as what? Phi. So you can also write down kinetic energy equal to h nu minus of phi. Anything they can give you. Anything. Now coming to even more important part. You have written one more point over there in the characteristics of photoelectric effect. Was that number of photoelectrons ejected, they are proportional to intensity of light. Now assume what I'm saying. Now see this thing. Suppose this is the metal whose work function, which is nothing but threshold energy, is given as say 5 electron volt. Yes or no? Now if one photon comes of say 8 electron volt, how many electrons will be ejected? How many electrons? Only one electron will be ejected. No, one electron. Only one electron, whose kinetic energy will be equal to how much? Come on. 3 electron volt. Are you getting that? Now, what I'm saying is that suppose if 2 photons are coming. I'll make it over here. So 2 photons are coming, and each of 8 electron volt, and the threshold is 5 electron volt each electron. Now electron will be ejected. They will have the kinetic energy of what? How much? 3 electron volt each. Kinetic energy will be equal to 3 electron volt each. Yes or no? 3 electron volts each. Hello? Each. So 2 photons will eject 2 electrons. Similarly, if third photon comes, it will eject one more electron, will eject one more electron. Will eject one more electron, and the kinetic energy will be 3 electron. Yes or no? Agree or not? Yes or no? So if I increase the number of photons, number of electrons ejected is increasing, but kinetic energy remains same. Kinetic energy is not changing. Yes or no? So can I say yes? Yes, Bharadwaj, very good. That the number of photoelectrons ejected is proportional to intensity. Intensity means number of photons coming in. Number of photons coming in. But kinetic energy is independent of intensity. Intensity means number of photons coming. Yes or no? Yes or no? So let me ask you one question. That suppose we are having 20 photons coming. 20 photons coming. And each having the energy of 8 electron volt. Each having the energy of 8 electron volt. And this is the metal surface. Who has the phi equal to 5 electron volt. Are you getting it? How many electrons will be ejected? How many electrons? 20 electrons will be ejected. 20 electrons will be ejected, and the kinetic energy of each electron will be how much? 3 electron volt. It will be 3 electron volt. Yes, good, good, very good, very good. Now, suppose we are having 25 photons coming. 25 photons coming. How many electrons will be ejected? 25. What will be the kinetic energy? 3 electron volt. So kinetic energy does not depend on the number of photons coming. Only what depends? Number of electrons being ejected. Number of electrons being rejected. Yes or no? Okay. So now understand one thing. So kinetic energy does not depend on intensity. Okay. Does not depend on intensity. So what is the graph of that? If I have got kinetic energy and I have got intensity, the graph will be what? A straight line parallel to intensity. Because intensity is increasing, but kinetic energy remains same. It remains same. It is not increasing. Sure about it? Constant. Now one more thing. That we are having over here number of photoelectrons. Number of photoelectrons ejected. And does the intensity. The graph will be like what? More photons, more electrons. Less photons, less electrons. And no photon, no electron will be ejected. Yes or no? So no photon means intensity is 0. Yes, it will be straight line and passing through origin. More intensity, more the photoelectrons ejected. 3 graphs, very, very important graphs. You should be doing these graphs. Very, very extremely important graphs. Okay? About it? Sure? Chaliye. Come over here. Now, there is something called stopping potential. Stopping potential. Say V naught. V naught. Please write down stopping potential, the definition of that. It is the minimum amount of potential required. It is the minimum amount of potential required. Correct. I mean, it is the minimum amount of potential required to stop the ejection of or emission of electrons, photoelectrons. To stop the emission of photoelectrons. Next statement, please. Write down. Next statement. When expressed in terms of electron volt, like EV naught, when expressed in terms of electron volt, it is equal to maximum kinetic energy of the photoelectron. It is equal to maximum kinetic energy of the electron. Very, very important. Very, very important. Let me explain this now. Okay? Chalo, dekho bachcho, aisa hai. Come over here. Now see what I'm saying. This is the glass tube. This is the cathode and this is the anode out here. Light was coming incident and we are assuming that this H nu is more than the h nu naught. So electrons are being ejected. And I'm saying that the kinetic energy is supposed to say 5 electron volt. How much? 5 electron volt. So even if I don't put any battery out there, if these electrons are having some kinetic energy, they will be able to reach over there. Yes or no? So as soon as the electrons reach there, the current starts flowing. Yes or no? Is that clear? Now suppose I put a battery in the opposite direction. This is now negative and positive. So this will become negative and this will become positive. So this positive will not allow the electrons to move. Moreover, this negative will also repel the electrons. Same charge will repel. Yes or no? Agree or not? If I put a battery in this fashion, this will become negative, this will become positive. So this negative will repel the electrons. Now suppose that if I put this battery in the position with the 1 electron volt energy, how much? 1 electron volt energy. What will be the kinetic energy of the electrons coming out? That means I'm opposing the flow of the current who were having the kinetic energy equal to 5 electron volt. I'm opposing them with 1 electron volt. What will be the net kinetic energy? 4 electron volt. Yes or no? Now if I increase it to 2, this opposing force is say 2. The electron is trying to come here with the kinetic energy of 5 electron volt. I'm opposing with 2 electron volt. It will be able to come outside still with 3 electron volt kinetic energy. Yes or no? Okay. Now I make it 4 electron volt. 4 electron volt. I make it 4 electron volt. It will come out with 1 electron volt. Now I make it 5 electron volt. Now what will happen? This electron is trying to come outside with 5 electron volt and I am pushing that with the equal and opposite force. Electron will not be able to come outside. Yes or no? Yes or no? This is called stopping potential. This is called stopping potential. The minimum amount of potential required to stop the flow of current. Yes or no? When you express this voltage in terms of electron volt, it is called the maximum kinetic energy of that electron being ejected. Yes or no, beta? Yes or no? Is that clear? Okay. So what I'm saying is that I have told you just right now that suppose if the kinetic energy is 5 electron volt, so the stopping potential, that will be EV naught, will be equal to how much? V naught is the stopping potential and expressed in electron volt will also be 5 electron volt in the opposite direction. In the opposite direction. Yes or no, beta? Yes or no, everyone? Jyotika, Suhas, Bharadwaj, everyone, Priyanka, Trishal, Jyotika, all of you getting that? Nayak, good, very good. So this will be same. Is that clear? Is that clear? Now, what I'm saying, now see that. If I start lessening this electron volt to 4, now what will happen? Some electrons will be starting coming and try to reach there. Yes or no? The current will start rising. The battery is 6. Okay, someone is asking if the battery is 6 electron volt. Suppose we are opposing with 6 electron volt. What will happen? We are opposing with 6 electron volt. Will the electron come out? No. Electron will not come out at all. Yes or no? If someone is trying to come outside with 5 electron volt energy and I'm pushing it with 6 electron volt energy. Yes or no? Electron will not come out. But this will not be called stopping potential. The reason being, it is the minimum amount of energy required. Minimum amount of energy required. The electron will not come outside even if I'm applying 7, 10, 20, 40 electron volt in the opposite direction. It will not come out. But the stopping potential will be defined when we say the minimum amount of potential required. Yes or no? Yes or no? So the minimum amount of energy required, when this is expressed in terms of electron volt, that will be called the stopping potential. Is that clear? There's someone who was asking that question. Clear? Okay. Now what I'm saying, this is not 5. I'm saying that, let's say, from 5, I decrease it to 4 electron volt. So, I mean, some electron will start moving Over there, 1 electron volt energy, and I make it 3, some more will go, 2, 1, and when I make it 0, almost all the electrons will reach there, which is equal to number of photons coming. Yes or no, beta? Are you getting that? Are you getting that? Let's see the graph. Let's see a graph. This is say current, and this is say potential. This is say potential. Okay, that is called V. And this is 0 volt, and here we will have negative voltage. Negative voltage. Agree or not? Suppose that I am assuming the maximum kinetic energy with which the electrons are coming is 5 electron volt. How much? 5 electron volt. Will you agree? Is 5 electron volt. But suppose over here, if I apply minus of 5 electron volt, minus of 5 electron volt means in the opposite direction. In the opposite direction. Yes or no? Will the electron come out? Will the electron come out? It will not come out. It will not come out because over here we are having this V naught as the stopping potential. Stopping potential. Yes or no? You can say negative, or you can say in the opposite direction, one and same thing. Okay? Okay, now if I start decreasing this potential from -5 to say -4, -3, -2, -1, so I believe that slowly and slowly the current starts increasing. Slowly and slowly the current starts increasing. Now over here I have removed the battery completely. I have removed the battery completely. Yes or no? That means there is no hindrance now. There is no opposition. There is no opposition. Yes or no? So if 10 photons are striking here, 10 photons are striking here, how many electrons will come outside? If 10 photons are striking here and there is no battery to stop it, 10 photons are striking, 10 electrons will come out. Yes or no? Is it possible that 10 photons are striking and 11 electrons will come? Is it possible? No, it is not possible. No, it's not possible. So if 10 are striking, 10 electrons will come outside. That means at this point, the current will be saturated. It will be saturated. Number of photons coming will be equal to number of electrons coming outside. Is that clear? There will be no more increment in the current. It's called saturation current. Saturation current. Saturation current. Okay. And for the intensity, I1. Intensity means number of photons. Number of photons. Are you getting it? So I'm saying that this intensity is supposed to be for 10 photons. How much? 10 photons. Now suppose there is a second case where 20 photons are coming. How many? 20 photons are coming. And I stop each of them with say minus of 5. How much? Minus of 5 electron volt. Will there be any current? No current will be coming. But I still keep on decreasing the opposition. It will start increasing. It will start increasing. It will start increasing. And once I make it 0 volt, no opposition. Now 20 photons are coming. How many electrons will be ejected? If 20 photons are coming, how many? 20 electrons will be ejected. That means more current will be carried out. Yes or no? But after that there will be saturation. There will be saturation current. Yes or no? And tell me for I2. I am assuming that I2 is more than I1. Yes, boys and girls? I2 is more than I1. Did you understood this diagram? Did you? Did you understand? Everyone? So over here, no current will be coming, and this V0 will be called, stopping potential. But if I decrease the potential, the electrons start coming outside, and at 0 voltage, when I remove the battery completely, all the electrons will be coming, which is proportional to what? Number of photons coming in. I hope that is done. I hope that is done by everyone. Sure about it? Okay. Now, understand that you people know that kinetic energy is equal to h nu minus h nu naught. I told you this kinetic energy is also equal to what? EV naught. So they can give you this also. So please don't get worried. Don't get worried. So depending on the question given, please keep on doing that stuff, okay? As per the merit. So now they can ask you one question like, which of the following graph is correct or incorrect regarding the photoelectric effect? For example, they can give you this graph, kinetic energy over here. This is frequency. This graph out here, Second graph they are saying is that this is the kinetic energy and this is the intensity. The graph is something like this. The third graph they are giving you is that this is the intensity, this is the number of photoelectrons ejected. Number of photoelectrons ejected. The graph they have given is this, and also they have given a graph of voltage. This is a voltage, yes or no? This is of say some minus of 5 electron volt, whatever it is, and like this. This is say for I1 kind of thing, you know? Which of the following graph is correct for photoelectric effect? Come on. 1, 2, 3, or 4. Which one? Come on. All are correct. All of them are correct. Okay. All of them are correct. Okay. So be careful with that stuff. Now, extremely important thing is that I have told you. Chalo dekhte hain. In which case, kinetic energy of photoelectron will be maximum. In which case, kinetic energy of photoelectron will be maximum. First, if I'm using the X-ray. Second, UV ray. Third, infrared ray. And fourth, equal in all. Come on. Which you believe? In which case the kinetic energy of photoelectron will be maximum. Some are saying X-ray, some are saying fourth. Beta, very good. Very good. Now see, if you remember, I taught you electromagnetic spectrum. And so like say over here, gamma rays, X-rays, UV rays. Here it was like say visible region, and infrared, microwaves, and radio waves. Is that clear? And I also told you that as I go from left to right, the frequency decreases and lambda will increase. But I also know that E is equal to h nu. That means E is proportional to frequency. More the frequency, more the energy. That means if frequency goes down from left to right, energy will also go down. Yes or no? So this will have the highest energy of photon, and this will have the least value of energy. The photon of radio wave will be having very less energy, and the photon of X-ray will be having very high energy. And I told you that kinetic energy of the photoelectron depend on what? The energy of the incoming photon. The energy of the incoming photon. Yes. So more is the energy coming, more is the kinetic energy of the photoelectron also. You have seen that or not, boys and girls? Forgot that. Suppose we are having, say, a 10 electron volt and threshold is 5 electron volt. Threshold is 5 electron volt, and for every electron. What is the kinetic energy? Come on. It will be 5 electron volt. Agree or not? Now photon is coming of 20 electron volt. Again, it is 5 electron volt. The kinetic energy will be equal to how much? How much? 15 electron volt. Will you all agree with me? Will you all agree with me? So more is the energy of the photon, more is the kinetic energy of the electron. Is that clear? So answer will be X-ray. X-ray does have the highest energy. Is that clear? Sure? Okay. So can we do some questions now? Can we go to some numericals? So first question I'm asking is that if the energy of photon is doubled, if the energy of the photon is doubled, the kinetic energy of photoelectron will be more than doubled. True or false? True or false? So we'll do it with the help of an example. And the reason is that the phi will remain same. We're assuming that phi or the work function remains same. So see that over here, let's say 10 electron volt, and this is 5 electron volt. We have done this right now. Previously also only we have done. Okay, we have done over here. See that? So in the first case, it is say 10 electron volt, and this will remain same. So the kinetic energy is 5 electron volt. But over here, since the energy of the photon 20 electron volt has doubled, kinetic energy has become almost 3 times, which is more than double. More than double. So this statement was true. This statement was true. Yes or no? There is no need for that. This is true. This is true. So can I give you a few more questions, numericals to solve? The simple one. So let's see them all one by one. Okay. So acha, one more thing you should know is that if they give you that energy required to stop the photoelectron to come outside is say 5 electron volt. What is the kinetic energy of the electron? Come on, that is also 5 electron volt. 5 electron volt. Very good. Very good. That we have discussed, hai na? So be careful when you see this thing. Be careful with that stuff. So let's do a question. So the question I'm giving you is that, come on, the energy required to stop the flow of electron, from copper plate. The energy required to stop the flow of electron from the copper plate is 0.24 electron volt. Is how much? 0.24 electron volt. Okay. Find phi, the work function, when lambda of photon is given as 5,000 angstrom. Come on. When lambda of photon is given as 5,000 angstrom. How you will solve it? So what they have given, first of all, understand that stuff. So energy required to stop the flow of electron from the copper plate is 0.24 electron volt. I believe this is nothing but kinetic energy given. Yes or no? Yes or no? Getting or not? And they're asking phi. So I know that kinetic energy is equal to h nu minus phi. But I have also taught you something. With frequency is not given, they are working with lambda. So can I write this thing as hc upon lambda minus phi? Can I write it? And also I taught you in the Planck's quantum theory that whenever energy is given in electron volt, then you can use this formula 12400 upon lambda if it is given in angstrom. Yes or no? So you can save yourself from the many calculations. Is that clear? Since over here the energy is given in terms of electron volt, I can use this formula. It will be 0.24 electron volt equal to 12400 upon lambda minus phi. Are you getting that, all of you? Are you getting that? So this 0.24 equal to 12400 upon 5,000 minus of phi. So see that this is gone, this is also gone. And what we can do? Okay. So, acha, see that? Okay, let's try that. This is also gone. This will be this thing, and this is say almost 125, है ना? So this will be like say 2.5. Will you all agree? So I can say that phi will be equal to 2.5 minus 0.24 approximately. You can give me the approximate answers, I mean, whenever you want. 0.24. How much you will be getting? But your phi will be equal to how much? 2.26 electron volt. Will you all agree with me that? 2.26. Will you all agree? All of you? Come on. Acha, in the same question, instead of this 5,000, if I give you the wavelength as 2,500, then what you will do? 0.24 equal to 12400 upon 2,500 minus of phi. Put it there directly. Just for the sake of practice, this will be 25 into 5 approximately. Will you all agree? And this will become phi equal to 5 minus 0.24 will be equal to 4.76 electron volt approximately. Yes or no? 4.76 approximately. So in this case, you can very well give the approximate answers. Sure about it? So can I ask you the next question? Come on. Please do this question. The energy required to eject an electron from a metal, the energy required to eject an electron from the metal is 2.5 electron volt. 2.5 electron volt. Find wavelength of, you can say, find lambda of photon required to just eject the electron. To just eject the electron. This question can be written in this format, or they can give you find the value of longest lambda. Longest lambda. When you say longest lambda, it means the energy must be minimum, because we know that energy is equal to hc upon lambda. Is it okay or not? Is it okay? Are you getting it out? So if the lambda is longest, energy will be minimum. So they don't want any kinetic energy. They simply want what? The electron to just come outside. That means kinetic energy should be 0. So if you apply this thing over there, the kinetic energy is equal to what? H c upon lambda minus of phi. This is 0, and if this is given in electron volt, I can write down 12400 upon what? Lambda in angstrom. Yes or no? In angstrom minus of phi, which actually means that phi will be equal to 12400 upon lambda, or you can say lambda will be 12400 upon phi equal to 12400. What is the phi given? Phi is given as 2.5 electron volt. Okay, so I believe I can write down this as 50, and that will be 5,000 angstrom. 5,000. Sorry, lambda will be 5,000 angstrom. Yes or no? Is that clear? Is that clear to all of you? Good. Now see, boys and girls, I mean, it's very important that you are staying very focused and having a super duper focus out here, you know. Like, see what happens. Many students, they believe that they can become doctors or engineers or whatever they want to become in their life by working hard. Trust me, boys and girls, I have never ever seen any hard working person becoming something. If working hard pays off, then show me a rich donkey. I have never ever seen a rich donkey, and I have never ever seen anyone working harder than donkey. So hard work is not the clue for a success. Smart work is. And the first thing to begin with the smart work will be to have a very high focus. Your focus should be very, very high. Are you getting it? Once your focus is very, very high, you will be able to eliminate all that is unnecessary. It's very important that you deconstruct the things which are not required. So you should learn to prioritize what is important and what is not important. Many times I see people that, I mean, sir, my goal is to score like say 710, 705, 700, 650, 620, whatever you can have any goal you want, you know? But trust me, students, I mean, setting these kind of goals is not going to help you much if you don't have that desire to excel. I see many students coming to me, sir, I want to score this, then this kind of score. I mean, but this is one thing, this is the life you want. But if your lifestyle is like that you are not having a good focus, your focus is gone, you are defocused completely. Moreover, you're busy in talking to your friends, you're wasting time, and you're sleeping every day now, and you keep on saying that you're thinking about the movies, the play, and all that stuff. This thing is never ever going to happen. Setting goals is one thing, but I mean, becoming successful is totally different thing. So rather than setting goals, I'll say that please make sure that you are having a very good commitment to yourself. That means you should be a very disciplined person, because you cannot stay motivated for an entire day, or even for a day. It might not continue for the coming days as well. So my point is that where the motivation ends, discipline begins. The discipline begins. Discipline will carry you where the motivation cannot. So rather than setting goals, bacho, please don't set goals this way. They're all empty. They're all hollow. Set basically what? Set a strong habit. You should create very strong system. Systems are made up of habits, and habits make your character. So rather than setting goals, make a very strong character. Once you are having a very strong character, a very strong habit, you will have a very strong system as well. And strong systems never fail. Never fail. Are you getting it? Because you will know that since I am bit weak in physics, I am bit weak in certain topics of chemistry also. So your job should be that whenever the morning begins, you will tackle the toughest things first. You will not bow down. You will solve the numericals, because many people believe that they can become doctors just by reading the notes or escaping the questions. Don't escape that. That will be quite detrimental for your progress. In NEET, they will not give you the theory to read. They'll give you 180 questions back to back to solve. And these days, they're giving you 200 at least to read. Are you getting it? Though you're having some choices, but the choice is not just to read it, solve it. The people will pay you for solving the problems. They will not pay you for reading the problems. So if you really want to become successful, please busy yourself in solving questions. Solving questions are very important. The only way to get the hell out of a problem is to solve it. There is no other way out. So please solve it. And one more thing, stop chasing the luxurious cars, stop chasing the luxury houses, stop chasing the dreams kind of thing. Rather than stop chasing the best version of yourself. Stop chasing a strong character. Once you're having a strong character, everything else will start chasing you. Trust me. You will not regret what I'm saying if you just admit that and execute that. So please don't make these kind of fallacies which many people make, rather than make a strong character. A strong character never fails. Never fails. It may take some time, but you will get over it. Strong character, strong systems will surpass the goals. You will have no idea what you can do. And I believe that 1 year is more than enough to change whatever you want to change. In full 1 year, even if this is sun, the earth takes the complete revolution. This distance is humongous, tremendous. In your entire lifetime, you will not be able to travel even this much also. If this can be done in 1 year, boys and girls, you can do whatever you want in single 1 year. Getting it? And it's not about orbiting the sun. It's just making sure that you are not having weak systems. Weak systems will fail. Strong systems will not. Strong systems, they depend on what? Strong habits. So develop some good habits, and you will not fail. Is that clear to all of you? Getting that or not? Come on. Is it okay or not? So what I'm saying, that's what I'm saying, that first learn and then remove L, and then you will keep on earning. But still I'll say keep on having that L. That L should not be temporary, it should be permanent. Okay, this L is permanent, so is LC. So keep both permanent in your life. Okay, and you will enjoy that stuff. I wish you all the best. So there is one more question left. So let's do it. Shall we do it? Okay, come on. So one more question. Let me drink some water. Let me drink some water. The last problem, you can solve it directly, but you have to give an explanation if someone is asking that, I mean, since kinetic energy will be equal to 0, when it is 0, the amount of energy the photon is required to make sure that the electron is just coming out, it should be equal to what? The phi only. So that means hc upon lambda should be equal to phi, and I know that when phi is given in electron volt, I can directly write down that phi is equal to 12400 upon lambda. Now whatever this value is given, suppose this is 2.5, so lambda will be 12400 upon 2.5 will be equal to how much? Almost 5000 angstrom. In atomic structure you can do very well, I mean, with the approximations. Yes, I am there in the offline campus only. I am in the boys campus. Yes, I am. Yeah, I mean, yeah, the energy is good out there. So at least in the physical classes, there is like feel is there. I can see the eyes of the people, the intensity of the people out there, and it's good to observe them and to inspire them to make sure that they are successful. Okay. Hero Shah Rukh Khan LC sir, or I'm not Shah Rukh Khan. I'm just LC. Okay. Okay. So let's one more question. Come on, boys and girls. Let's do one more question, and that question is that light of lambda equal to 4000 angstrom is incident on a metal of phi equal to 2.13 electron volt. 2.13 electron volt. Find the kinetic energy of photoelectron ejected. Find the energy of kinetic energy of photoelectron ejected. Come on. Now again, there is energy which is mentioned in terms of electron volt. So can we handle that? Yes, we can. And I have got an answer from someone. So Priyanka is the first one to give the answer. Vikram, check it out. A blunder is there. Trishal is good. Very good. Keep it up. I want everyone else. Suhas, please give me the answer. Nayak, your answer is waiting. Rakesh, Jyotika, all of you, please. So, I am asking the kinetic energy. You are giving the answer in electron volt. Oh, this angstrom. Suhas, I'm not asking angstrom. Yes, Saujanya, very good. Very good. So let's see that. I believe that I can say. Okay, so kinetic energy is equal to, what is that? Hc upon lambda minus phi. So they have given this part, and energy is given electron volt. So I can say very fiercely, it will be 12400 upon lambda, which must be an angstrom, minus of 2.13. So boys, if you allow me, I can write down it very well, equal to 12400 upon lambda. How much lambda? Bare bolo re. Lambda equals to 4000 minus 2.13. This is gone. This is also, there will be 3.1 minus 2.13 is equal to how much? 0.97 electron volt. Agree or not? Yes, Priyanka, Jyotika, something went wrong. Maybe some blunder was there, but the point is that you're all getting that. You're all getting that stuff. Sure about it? Sure. Okay. Approximate, I mean, it should be less than 1. Vikram, you're correct, but it should be less than 1. Okay. Even if you say 0.96, 0.98, I'll agree. But 1.1 may be bit on the other side. Because in these kind of questions, it is quite possible that they can give you something less than 1 and something just more than 1. So if you are having a common sense, your answer will be coming just less than 1, but not more than 1. Keep it up, boy. Keep it up. You're doing good. Very good. Very good. So like one more question coming up. And it says that in the next question, they're given the threshold frequency is given as 6 into 10 to power of 14 hertz. This is the threshold frequency given. This is the threshold frequency given. And the question they're saying is that this metal is exposed to light, having energy equal to, say, 3 into 10 to power of minus 19 joule. 3 into 9 to power of 10 to power of minus 19 joule, or you can say 3.5 rather, 3.5 10 to power minus 19 joule. है ना? The kinetic energy of light. Light means here photon. है ना? Means photon. The question is, will it show photoelectric effect or not? Will it show photoelectric effect or not? Come on, do it. Do it all of you, please. Priyanka says no. Vishal also says no. That is good. Very, very good. Even is the right answer. Preeti also saying that. Saujanya joins us. Very good. Very good. Come on. So this is the energy of the photon. This is actually h nu. This is h nu. Let's calculate h nu naught. Let's calculate h nu naught. Oh, someone saying that Suhas is saying it will show. Suhas, you are the only one who is saying so. Otherwise, all of them are saying it will not show. Okay, let's check that. So h is 6.6 10 to power of minus 34 into 6 into 10 to power of 14. So if you'll check it out, it will be 10 to power of minus 20. Now 6.6 into 6 is 39.6 into 10 to power of minus 20. Since the power is 10 to the power minus 19 here, I should try to make the powers at least same. So this can be written as 3.96 into 10 to power of minus 19 joule. Yes or no? Now, I know that this h nu naught is more than h nu So if h nu naught is more than h nu, it will not show any photoelectric effect, because I have taught you to get photoelectric effect. What is the condition? What is the condition? H nu should be more than h nu naught. Yes or no? That's the condition required. Okay, this is not required. Getting it? All of you? Threshold energy is 3.96 10 to the power minus 90 joule. This is threshold. This is called phi, or you can say threshold, one and same thing. One and same thing. Okay? Good one. So let's do the last question now. Shall we do last question? Chalo, come on. So here's the last question coming up, and it is like, say, a gas absorbs a photon of lambda equal to 300 nanometer and re-emits two photons, lambda 1 of 1 photon re-emitted is equal to 400 nanometer. Find lambda 2 of other photon re-emitted. Come on, solve it. Come on, solve it. So the question is that if there is a photon coming up, this is having energy E, is absorbed by a gas particle which re-emits which re-emits two other photons with energy E1 and say E2. So we will be applying the conservation of energy over here. Are you getting it? The energy of this photon will be equal to sum of the energy of the remaining or the re-emitted photons. Will you all agree? Yes or no? Yes or no? That actually means E will be equal to E1 plus E2. Now the focus is what? Wavelength. So I should be talking in terms of wavelength. So it will be hc upon lambda equal to hc upon lambda 1 plus hc upon lambda 2, because all photons travel with the same speed. And this hc can be cancelled. 1 upon lambda is equal to 1 upon lambda 1 plus 1 upon lambda 2. Yes or no? Yes or no? So now we have to just solve it, and it will be 1 upon 300 equal to 1 upon 400 minus 1 upon lambda 2. 1 upon lambda 2, I can rearrange it. It will be 1 upon plus. It will be plus. My mistake. So 1 upon 300 minus 1 upon 400. So 1 upon lambda 2 will be, take the LCM. This will be 1200. It will be how much? 4 minus 3. Yes or no? Come on. So 1 upon lambda 2 will be equal to 1 upon 1200. I can say very safely lambda 2 will be equal to 1200 nanometer. Please mind the units as well. How many got? No, it's not angstrom. Vikram, it's nanometer. No, nanometer, because data given is in nanometer. This is all nanometer. So lambda 2 will also be in nanometer. Acha, okay, you are saying either 1200 nanometer or 12,000 angstrom. One and same thing. Okay, good. Good, Vikram. Very good. So how many got the answer? Jyotika got it. Trishal got it. Vikram got it. I saw that. Priyanka got it. Good one. Very good. Very good. Saujanya got it. Okay. Bharadwaj got it. Very good. Vikram, Bharadwaj, everyone. Take it. Nayak got it. Got it, everyone. Vishal got it. Take it. Okay. So now one last thing is left, bachcho, hai na? Last thing is left with respect to the spectrum, hai na? Just spectrum. I mean, they ask you normally one question from that, hai na? So my task is to teach you one thing, that what is line spectrum and band spectrum. Okay. So remember that in line spectrum, we are having, first point is well-defined lines. We have got well-defined lines. And over here, lines are closely spaced. For example, over here, what happens? Lines are very, very far. They're very distinct. So you can catch it. I mean, there's no problem. But over here, they're very, very close, very, very close. So from far, it will look like they're almost a band. They're almost like a band. Yes or no? So this is the band spectrum. Secondly, it is due to the movement of electrons. You all know that electrons can move from higher to lower orbit. And when they do it, they will emit a photon or emit the light, which will be found in the form of these lines. Yes or no? But over here, remember that this band spectrum is due to what? Vibration of atoms or the ions in a molecule. So this is shown by whom? Molecule. Band spectrum is the characteristic of molecule. Yes, very good. Is a characteristic of molecule. Very, very important. I mean, again, third point, it is shown by atoms. And third, it is shown by molecules. Now over here, you can see the example, any discrete atom, like say neon gas, any noble gas, or you vaporize a metal, so the metal atoms are formed. These atoms will give you line spectrum. But if we're talking about, like say, a total metal, I mean, like say, which is like, or like say non-metal, like say, we can have say P4 kind of thing. Are you getting it? S8 kind of thing. So these are the molecules, CO2, all these. They will, whenever they will give you, they will show you a band spectrum. Sure about it, everyone? So that will be the end of the lecture today. That's all for me for this time. Your syllabus contains the line spectrum and band spectrum, photoelectric effect, and black body radiation. Are you getting that? So just do it seriously. They will be sending you the weekend syllabus as well. I wish you all the best. God bless you. Bye-bye. Take care. All the best. Okay, I'll send you that also. Share you the code. Bye, bachcho. Bye-bye.